Hello everyone, and welcome. Today, we are going to step quietly into the distant past far beyond blueprints, power tools, and modern engineering and look at something that still leaves experts puzzled: the incredible construction achievements of ancient civilizations. All across the world, long before modern technology existed, people built structures that continue to stand today. Massive stone temples, towering pyramids, fortified cities, and precisely aligned monuments were created with a level of accuracy that feels almost unexpected for their time. Even now, with advanced machinery and computer modeling, engineers often pause when studying these ancient works and ask a simple question: how did they do this? What makes these structures so remarkable is not just their size, but their precision. Stones weighing many tons were cut, shaped, and placed with extraordinary care. In some ancient buildings, blocks fit together so tightly that no binding material was needed at all. Walls remained straight, corners remained sharp, and foundations remained stable after centuries or even millennia of weather, movement, and natural change. Modern experts can propose theories, recreate small-scale experiments, and suggest possible methods. But when it comes to fully explaining how entire civilizations consistently achieved this level of construction across vast regions, the answers become less certain. The challenge is not a lack of intelligence or effort today, it is the absence of complete records from the past. These ancient builders did not leave behind instruction manuals or technical drawings. Their knowledge lived in hands, eyes, and experience, passed from one generation to the next. When those lines were broken by time, conflict, or change, the techniques faded, leaving only the finished structures behind. And so, we are left standing in their shadow, impressed, curious, and quietly wondering how much human knowledge once existed, only to slip beyond our reach. Tonight, we begin exploring that mystery. For much of human history, construction knowledge was not preserved in written form. Instead, it was carried through direct experience, through observation, repetition, and long years of practice. Master builders trained apprentices by working beside them, correcting mistakes in real time, and passing down techniques through demonstration rather than documentation. Skill lived in the body as much as in the mind. This system was remarkably effective. It allowed complex methods to be taught without formal education, mathematics, or written language. Builders learned how stone behaved under pressure, how weight shifted across structures, and how materials responded to weather and time. These lessons were absorbed gradually, often over decades, until techniques became instinctive rather than theoretical. However, this strength was also a vulnerability. When knowledge exists only in people, it disappears when those people are gone. Wars, migrations, natural disasters, and social collapse could break the chain of transmission in a single generation. Once master builders were lost, their skills could not be easily recovered by those who followed. Unlike modern societies, ancient civilizations rarely recorded construction processes in detail. Writing, when it existed, was reserved for religious texts, trade records, or political power, not for technical instruction. As a result, future generations inherited the structures themselves, but not the understanding behind them. This is why modern researchers can measure ancient walls, analyze tool marks, and study materials endlessly, yet still feel something essential is missing. The knowledge was never meant to be frozen in words. It was alive, adaptable, and deeply human. What remains today are silent monuments, precise, durable, and stubbornly resistant to full explanation. They stand as evidence not only of what ancient people built, but of how much they once knew, and how easily that knowledge can fade when it is carried only by memory and practice. Across many ancient sites, one detail stands out immediately: the astonishing precision of the stonework. Blocks carved thousands of years ago fit together with a level of accuracy that still surprises modern engineers. In some places, the joints between stones are so tight that even a thin blade cannot slide between them. No binding material was used, yet the structures remained stable after centuries of natural wear. What makes this even more remarkable is the type of stone involved. Granite, basalt, and other extremely hard materials were shaped with smooth surfaces, sharp edges, and consistent angles. According to conventional understanding, working stone of this hardness requires advanced metal tools, high-speed cutting equipment, or industrial abrasives. And yet, many ancient cultures are believed to have worked with tools made from softer metals or stone itself. Modern experiments have shown that it is possible to shape hard stone using simple tools, but doing so with such consistency across entire cities and monuments would require an extraordinary level of skill and time. The question is not whether ancient builders could cut stone, but how they achieved such uniform results on a massive scale. Another mystery lies in the absence of clear tool marks. In some locations, the surfaces do not show patterns typical of chisels, saws, or drilling methods known today. This has led researchers to suggest alternative techniques, including abrasion with natural compounds, controlled pressure, or methods that have not survived into the modern era. The precision itself may have served more than an aesthetic purpose. Perfectly fitted stones distribute weight evenly, reduce weak points, and increase long-term stability. This suggests that ancient builders understood structural behavior deeply, even if they expressed that knowledge through practice rather than theory. What remains today is stone shaped with confidence and intention, evidence of techniques refined over generations, then lost. The structures endure, but the methods that created them remain one of history's most enduring puzzles. One of the most difficult questions surrounding ancient construction is not how stones were shaped, but how they were moved. Across deserts, mountains, and uneven terrain, ancient builders transported stone blocks weighing tens or even hundreds of tons. Many of these stones came from quarries located far from their final destinations, sometimes miles away, sometimes across water. Without engines, metal rails, or powered cranes, this task would have required careful planning and deep understanding of physics, balance, and terrain. Archaeological evidence suggests the use of sleds, rollers, ropes, and large teams of workers. Some relief carvings even show stones being pulled across the ground while liquid is poured in front of them, possibly to reduce friction. Yet these images offer only partial clues, not complete explanations. What makes the problem more complex is scale. Moving a single large stone as an experiment is one thing. Repeating the process thousands of times, with consistent results, over years or decades, is something else entirely. The logistics of feeding workers, coordinating movement, and preventing damage to the stone would have required advanced organization and experience. In some locations, stones appear to have been transported uphill or across uneven landscapes where simple dragging methods seem insufficient. This has led researchers to propose the use of temporary roads, earthen ramps, wooden frameworks, or counterweight systems, most of which would leave little trace after being dismantled. Because these transport systems were likely built from organic materials like wood and rope, they rarely survive in the archaeological record. What remains are the stones themselves, already in place, offering no direct evidence of the journey they took. The result is a quiet but persistent mystery. Ancient builders clearly knew how to move the impossible. They did it repeatedly, efficiently, and with confidence, leaving behind monuments that force modern observers to reconsider what human ingenuity can achieve without machines. In regions where the ground frequently shifts, ancient builders developed architectural solutions that allowed structures to survive repeated seismic activity. Long before modern engineering standards existed, these civilizations observed how buildings failed and quietly adjusted their designs to endure movement rather than resist it. Instead of rigid walls, many ancient structures were built with interlocking stone blocks that could shift slightly during an earthquake and then settle back into place. This flexibility reduced internal stress and prevented catastrophic collapse. Open spaces, inward-leaning walls, and carefully balanced weight distribution all contributed to greater stability. Doorways and windows were often trapezoidal rather than rectangular. This shape helped spread forces more evenly and reduced the risk of stones falling inward. In some cases, foundations were intentionally designed to be layered or loosely fitted, allowing the structure above to move independently from the ground below. What is striking is that these techniques were not the result of mathematical modeling or written theory. They emerged from observation and experience, lessons learned through time, failure, and rebuilding. Builders watched which structures survived and which did not, then refined their methods accordingly. Many of these ancient buildings remain standing today in areas that continue to experience earthquakes. Meanwhile, newer constructions, built with rigid materials and less adaptable designs, have sometimes failed under similar conditions. This contrast has led modern engineers to revisit ancient methods for inspiration. The success of these designs reminds us that resilience does not always come from strength alone. Sometimes, it comes from understanding movement and allowing space for it. Ancient builders may not have described these principles in words, but they expressed them clearly in stone, creating structures that could move with the earth, rather than break against it. Among the most surprising achievements of the ancient world is a form of concrete that appears to improve with age rather than weaken. Structures built by the Romans nearly 2,000 years ago, especially ports, harbors, and seawalls, continue to endure constant contact with water, waves, and salt. In similar conditions, many modern materials show visible damage within decades. For a long time, this durability remained unexplained. Roman builders used a mixture that included volcanic ash, lime, and seawater, creating a material that behaved very differently from modern cement. When exposed to water, chemical reactions occurred within the concrete that slowly strengthened its internal structure instead of eroding it. Microscopic studies have shown that this concrete forms new mineral bonds over time, filling cracks as they develop and reinforcing weak points from within. This process happens gradually, without human intervention, allowing the structure to remain stable across generations. The result is a building material that adapts to its environment rather than resisting it. What makes this knowledge particularly fragile is that the Romans did not leave behind detailed recipes or instructions. Their understanding of materials came from experimentation and tradition, not from standardized formulas. When access to volcanic materials changed and construction practices evolved, the method quietly disappeared. Modern engineers have begun studying these ancient mixtures in an attempt to recreate their properties. While progress has been made, exact replication remains difficult. Subtle details such as sourcing, timing, and environmental conditions may have played a critical role. Roman concrete challenges the assumption that technological progress always moves forward. It suggests that some solutions were once discovered, refined, and then forgotten. What remains is not just stone and mortar, but evidence that ancient builders understood materials in ways that modern science is still learning to appreciate. Raising massive stone blocks into position was one of the greatest challenges faced by ancient builders. Without electric power, steel cables, or modern cranes, they still managed to place multi-ton stones high atop walls, temples, and monuments with remarkable accuracy. The precision of their placement suggests not improvisation, but carefully planned systems refined through long experience. Evidence points toward the use of ropes, wooden frameworks, ramps, and pulley-based mechanisms. Counterweights may have been used to reduce the effective load, allowing fewer people to control heavy stones safely. Some lifting systems were likely temporary, dismantled once construction was complete, leaving little trace behind. What complicates modern understanding is the absence of full designs or surviving machines. Unlike stone structures, wooden devices decay quickly, especially in harsh environments. As a result, archaeologists must infer lifting techniques from indirect clues, such as wear patterns on stones or the spatial layout of construction sites. In some cases, stones were placed in positions that seem almost inaccessible by simple ramp methods alone. This has led researchers to suggest more complex mechanical systems, possibly involving multiple stages of lifting or rotating platforms. While experimental reconstructions have shown that such systems are feasible, none can be confirmed with absolute certainty. The success of these methods required more than strength. It demanded coordination, timing, and trust among workers. A single mistake could damage materials or end lives, so precision and planning were essential. These ancient lifting achievements remind us that advanced engineering does not always require advanced technology. With a deep understanding of balance, force, and teamwork, ancient builders accomplished tasks that still inspire admiration, leaving behind structures that seem to defy the limitations of their time. Some ancient stonework presents marks that do not align with the use of chisels, saws, or drilling tools typically associated with manual carving. Surfaces appear smooth yet irregular, as if the stone was encouraged to separate rather than forcibly cut. This has led researchers to consider the possibility that heat played a role in shaping stone. One proposed method involves controlled heating followed by rapid cooling. When stone is exposed to high temperatures and then cooled suddenly, internal stress can cause it to fracture along predictable lines. By carefully managing this process, builders may have been able to split large blocks with surprising accuracy, reducing the need for extensive cutting. This technique would have been particularly useful when working with very hard stone, where traditional tools wear down quickly. Fire, fuel, and water were widely available resources, making this approach practical in many environments. Over time, repeated experimentation could have allowed builders to refine the process and control the results with confidence. Because heat-based methods leave subtle traces rather than clear tool marks, they are difficult to identify conclusively in the archaeological record. Weathering and erosion further obscure any evidence that may have once existed. As a result, these techniques remain largely theoretical. If such methods were used, they highlight an important aspect of ancient engineering, working with natural forces rather than against them. Instead of overpowering stone through brute force, builders may have guided its behavior using temperature, timing, and patience. These possibilities suggest that ancient construction was not limited to simple hand tools. It may have included a broader understanding of materials and natural processes, knowledge gained through observation and practice, and later lost when those traditions faded away. Some ancient structures reveal a careful awareness of how sound moves through space. In certain temples, chambers, and open plazas, voices carry farther than expected. Echoes behave in unusual ways, and specific tones seem to resonate more clearly than others. These effects were not accidental. They suggest deliberate planning and a deep sensitivity to acoustics. Builders appear to have shaped spaces to enhance communication, ceremony, or collective experience. Curved walls, stepped surfaces, and precisely spaced elements can reflect or absorb sound in controlled ways. Without written theory or measuring devices, these results likely came from repeated testing, listening, adjusting, and refining designs over time. Geometry played an equally important role. Many ancient structures rely on consistent proportions, repeating patterns, and carefully balanced layouts. These geometric choices created harmony, stability, and visual order, but they also affected how forces moved through the structure. Shape was not only aesthetic, it was functional. In some cases, geometry guided movement, drawing people towards central spaces or directing attention toward specific focal points. This suggests that builders understood how humans experience space, not just how materials behave within it. What is remarkable is that these effects often persist today. Visitors can still hear echoes, feel shifts in atmosphere, and sense intentional design even without understanding why it works. Modern analysis can describe these phenomena mathematically, but it cannot fully recreate the intuitive process that led to their creation. These structures remind us that ancient builders worked with more than stone and mortar. They shaped experience itself, using sound, proportion, and space as tools. The knowledge behind these choices was subtle, experiential, and rarely recorded, making it one of the most elusive aspects of ancient construction to recover. Many ancient structures were positioned with remarkable accuracy in relation to the sun, the moon, and the stars. Temples, monuments, and ceremonial spaces often align with solstices, equinoxes, or specific celestial events that occur only once or twice a year. These alignments suggest careful long-term observation of the sky and a precise understanding of cycles far larger than a single human lifetime. What makes this especially striking is the absence of modern measuring instruments. Without telescopes or advanced mathematics, ancient builders tracked shadows, sunrise points, and seasonal changes over generations. Small adjustments, repeated year after year, allowed them to fix exact orientations within the landscape. These alignments were rarely decorative. They carried meaning, marking moments of transition, renewal, or collective gathering. Light entering a chamber at a specific hour, or casting a shadow along a precise line, transformed architecture into a kind of calendar, one made of stone rather than paper. From a construction perspective, this required planning long before the first stone was placed. Builders had to account for terrain, horizon lines, and the gradual movement of the sky across seasons. Once construction began, there was little room for error. A slight miscalculation could break the alignment entirely. Because this knowledge relied on observation and tradition rather than written formulas, it was fragile. When cultural continuity was disrupted, the reasoning behind these orientations faded, even though the buildings remained. Today, we can measure and confirm these alignments with modern tools, but the mindset that created them remains difficult to grasp. These structures reflect a worldview in which architecture, time, and the cosmos were deeply connected, in understanding shaped slowly, patiently, and then left behind in stone. Ancient construction techniques were deeply tied to the societies that created them. They depended on stable communities, long-term planning, and generations of shared experience. When those societies changed or collapsed, the knowledge that sustained their building traditions often vanished with them. Political shifts, environmental change, resource depletion, and migration could all disrupt the continuity required to preserve complex skills. When cities were abandoned or populations declined, master builders lost apprentices, workshops fell silent, and unfinished projects were left behind. Without a living chain of instruction, techniques that took decades to learn could disappear in a single generation. Unlike modern industries, ancient construction did not rely on standardized documentation. There were no universally shared manuals, no formal institutions dedicated to preserving technical knowledge. Skills survived only as long as they were practiced. Once buildings stopped, understanding faded quickly. In many cases, later cultures reused ancient structures without fully understanding how they were made. Stones were repurposed, walls repaired, and foundations rebuilt using simpler methods. Over time, original techniques were overridden by newer, less complex ones, further obscuring the past. This loss creates a gap between what we can see and what we can explain. The structures remain solid and visible, but the processes behind them are absent. Modern researchers are left piecing together fragments, tool marks, material composition, and construction patterns without access to the human experience that once guided every decision. The disappearance of this knowledge is a reminder that progress is not always permanent. Human understanding can move forward, pause, or even retreat. What ancient builders achieved was not guaranteed to survive simply because it worked. When the cultures that sustained it fell away, their knowledge followed, leaving behind enduring monuments and unanswered questions. Standing before ancient structures, it is easy to assume that something essential has vanished forever. The stones are still there, carefully placed and enduring, yet the methods behind them feel distant and unreachable. This has led many to describe ancient construction techniques as lost. But that word may oversimplify a more complex reality. In some cases, the knowledge may not be entirely gone, it may simply exist outside modern ways of thinking. Ancient builders worked without strict separation between science, craft, and daily life. Observation, intuition, and long-term experience guided decisions more than formulas or written theory. What they knew was practical, adaptive, and deeply connected to environment and culture. Modern research often tries to isolate single techniques, tools, or materials. Ancient construction, however, was likely a system combining material choice, climate awareness, labor organization, timing, and tradition. Removing one element from that system can make the rest appear impossible to reproduce. There is also a tendency to underestimate the past. When modern expectations are applied too rigidly, ancient achievements seem unnatural or mysterious, rather than the result of patient refinement over generations. What appears extraordinary today may have once been ordinary to those who practiced it daily. At the same time, some knowledge truly has faded beyond recovery. When skills are not recorded and no longer practiced, they cannot be fully reconstructed, only approximated. Experiments can suggest possibilities, but certainty remains out of reach. This uncertainty is not a failure of modern understanding. It is a reminder of how fragile human knowledge can be. What survives is not always what was most advanced, but what was most easily preserved. Ancient construction leaves us with more than impressive monuments. It leaves us with humility and invitation to recognize that human ingenuity has taken many forms across time, some of which do not fit neatly into modern explanations, yet remain deeply worthy of respect. As we reach the end of today's journey, what remains is not a single answer, but a broader sense of perspective. Ancient construction was not built on mystery or myth, but on patience, observation, and generations of accumulated experience. These builders worked closely with their materials, their landscapes, and the rhythms of time itself. What they created continues to stand, quietly reminding us that human ingenuity has always been deeper and more adaptable than we often assume. The techniques explored today may never be fully reconstructed, and perhaps they were never meant to be. Some knowledge belongs to the moment in which it is lived, shaped by culture, environment, and shared understanding. When those conditions change, the knowledge changes with them or fades away. Yet the structures remain. They invite curiosity rather than certainty, reflection rather than conclusions. In their silence, they encourage us to slow down, to look more closely, and to respect the intelligence of the past without forcing it into modern definitions. Thank you for spending this time exploring history with us. If you found this journey calming or thought-provoking, feel free to stay, listen, and return again. Until next time, take care and have a peaceful rest.